Hello, class, and welcome to Code It, Drive It Week 1. This will be an introduction to the Vex Virtual Robot playground, as well as we're going to get into some of the basics of block style programming that really underlie all of the programming that we'll get into throughout the rest of the course. Since this is our first week, we'll start out with a bit of an introduction to why are we all here and what the course is going to be about. And then we'll try and get right into the fun stuff, playing around in the virtual robot environment and learning about the basics of programming. Couple notes about the course. Obviously, it would be nice to have everybody's cameras on if that's at all possible. It just makes it much nicer to actually interact with you guys. I really look forward to getting to know you a little bit over the course of the 8 weeks. Feel free to participate, ask questions. You can raise your hand on camera and I'll be able to see it. We're a pretty small group. It's not going to get that too crazy. But you can also use the chat, I think, to send out a note, and then either Drew or I will notice it. If I'm just rambling or something, somebody let me know. And then we're going to keep evolving this course as we go. So feel free to, again, let me know if I'm going too fast, going too slow. If there's anything that I don't do a good job of explaining, please let me know, and I can try and do better on that part of it for next time. In general, again, I'm very free for changing how we do this on the fly. But for now, my thought is that every week we would start with a little bit of an introduction, get right into a lesson that I'll try and keep the sort of me just talking at you as short as possible. That's not what we're really here for. But then I'll give you a challenge, a little mini challenge that we can separate you all out into breakout rooms that you can work with each other and try and solve the challenge. Meanwhile, I'll float around to the different rooms and answer questions. Then we'll come back together for a second lesson. Again, I'll try and keep that on the short side. And then we can break out again, either independently or you can work together again on sort of a larger challenge for the day. And then we'll get back together one more time at the end to talk about what are we doing next time, how did today go, is there anything that we need to change or clarify. Makes sense for those of you in the class today that we should start off with a little bit of introductions. I don't know you, you don't know me, but I can start. As far as the whole icebreaker situation, I'm not a huge fan of that, but it's always fun to see what people do. So I'm actually going to ask you, instead of for your answer to one of those icebreakers, what is your favorite or least favorite icebreaker that people ask you in these sorts of meetings? And then what I will actually ask you is what comes to your mind in terms of real world programming or robotics. And I'm going to try and have you guys not repeat each other. So, hey, the sooner you speak up, the less likely it is someone's going to take your answer. So I'll go first. My name's David Hurt. I'm a big fan of two truths and a lie when it's done well, and it gets really boring if it's not done well. So that's I usually use strange foods that I've cooked. I really enjoy cooking, and so I've cooked ostrich meat before. I've cooked rabbit meat before, but I've never cooked dog before, and so that I would say something like that. So I have two examples that I'll give. One, my job every day, I deal with data analysis and programming in Python to look at battery lifetime and battery percentage algorithms. I think everybody knows that it's very tricky and inaccurate. What your phone or laptop is telling you is your percentage. Very rarely does a good job at it. So that's what I work in every day. And then as far as robotics in the real world, my little brother actually works full-time on satellite controls. And so he works with a variety of companies that launch satellites and helps design the stability systems, making sure they stay essentially where they're supposed to be. So we can go around the room and hopefully take some time and at least initially get to know each other. I'm sure I'm going to have to reintroduce, people are going to have to reintroduce themselves a bunch because I'm just terrible with names. So That sounds really good. And who wants to start? All right. I'm excited. I took some notes, but it'd be good to see how many of these did we hit. So the ones that came to mind when I was planning this to try and come up with new ideas to throw out there. So for programming, we can talk about things like machine learning and artificial intelligence. Data processing work is where I do a lot of my programming, and really that can be useful in almost any type of job. Once you have the tools for basic data processing, it makes it so much easier to do so many things instead of working in Excel or just on your calculator all day. Graphic design and game engines, all of game design nowadays, you don't necessarily have to be deep into the programming to use those tools, but the people who create the tools that are really at the forefront of modern game design, all of that is working on tools that they develop themselves. The Unreal Engine being the biggest one that comes to my mind that's most impressive. And then sort of something that might not be so obvious, nowadays a huge amount of the stock exchange and financial trading is actually done by trained robots or programs really that can trade these tiny little transactions to make money much, much faster than any human ever could. Um, so on the robotics side, some of this is a little bit more obvious where programming and robotics come into the real world. It's an incredibly well industrialized field at this point. So factory automation is and getting robots to work with one another to accomplish a task, as well as getting them to work with humans. And then that brings to mind robot assisted surgery is a huge and crazy complicated field of modern robotics where you're allowing a surgeon to get more finesse than a human could ever get with their scalpel and knives and stuff. Um, so that's incredibly dangerous and incredibly cool side of the robotics field that I don't always think about. Then obviously you have rovers and drones and self-driving vehicles. All of those are essentially the same type of robot. They're just being used for all kinds of incredibly different things, from driving on other planets to taking a video of your backyard to, dropping bombs on people who are going to have bombs dropped on them. So again, it's a lot of ways that robots get used in this world, and it's a lot of, good experiences and money to be made playing around with all kinds of programming in robots. So I think that's a relatively solid sell of both the value and the variety of things. You're really, when you go into programming and robotics, you're super duper not backing yourself into one particular job or another. What you're really doing is building a toolkit for almost anything that you could want to be working on in the future. So now when we talk about programming here, first we're going to talk about the Vex block style programming. But one of the biggest takeaways, I think, from this course is going to be an introduction to Python language specifically. The Vex does a really good job of getting you started with block programming and letting you transition into using Python, which is the most popular and fastest growing programming language in the world by a lot of metrics. It is hugely useful, as I said, for a ton of very different types of project. And the other reason why it's growing, why it's so popular, is that it's designed to be written and read and understood by humans, where the under the general philosophy of you might only write this code once, but you in the future and a dozen other people are probably going to have to read and understand how and why you wrote this that way. And so it is a language that is designed like a human language to facilitate people working together and building something as a community that's bigger and more powerful than any one program you would write on its own. So that's why Python, but why Vex Robotics? Vex is an educational company that provides robot kits, and every year they make challenges for students to compete, to bring competition and sort of that nature of things that makes projects like this so much more engaging to work on. In addition, last year, Vex actually debuted their Vex Virtual Robotics platform, which was incredibly, well timed for the whole world to shut down. But so that's how we're going to be doing the first half of this course is going to be all done, explained and tested using the Vex Virtual Robot Playground that we're going to get into today. It's really easy to use, and it does a really good job of showing you reliably how to control your robot in a bunch of different ways to accomplish. Again, they've got challenges as well that you can run to solve problems with their system. Okay, let's get into it. So, in general, the structure of the course is going to be three phases. First, this week and for the next couple weeks, we'll really live inside of the Vex Virtual Robot Playground using blocks in order to do the programming that we're doing, and really focus on the key elements of programming that are going to be useful throughout your future, no matter what languages or type of programming you're going to work on. Starting in week 3, I think we're going to start looking under the hood of what functions and Python coding specifically means and how to work with that, and what's different between that type of programming and block programming. And then hopefully we're going to start transitioning away from the virtual platform into setting it up so that you guys can send your code online, and we can run it on our bots in real time that we have either where I am here or at the makerspace in Connecticut. Then at the end of the course, we'll have some bigger challenges that we want you to work on, and then we'll focus on having some guests and sort of figuring out what are the various directions that you can go from here, launching yourself into STEM, robotics, programming specifically, depending on what you feel the most interested in. All right, without further ado, I'm a big believer in sort of telling you what I'm about to teach before I start teaching it. So when we break into the small groups, we're going to get right onto, here's the link, and then I'll say it again another dozen times, I'm sure, to go to the Virtual Robot website. We're going to look at how is it laid out, how to use it, what are the different types of blocks that you can use to create your programming. We're going to test it a little bit together, and then we're going to set you free and have you explore what you can do with the robots. All right, so when you load up a new project, you see this screen. They've got a tutorial there that you can play if you want or close it. They've got actually quite a lot of tutorials. I'll show you where to grab those at the end of this. But first thing we're going to talk about is again, there's this big list of blocks that you can use. And we'll talk about how do you manipulate those. Can see they've got some numbers you can enter. They've got drop-down menus. We'll talk about that. All of the big white space here is where you're going to actually build the code that you run, either sort of top to bottom or in separate chunks. And we'll talk about how to build it together with the blocks. And then we'll talk about running it into the virtual playground and playing around and testing and iterating on tests. Do something, see if it works. Do something, see if it works. We'll mention a little bit these guys here that are sort of bonus. We'll work a lot with those stuff later in the course, I think. But for instance, that first one shows you the Python code that would be the exact same thing as all the blocks that you've made. And so that'll be really useful when we start getting away from the blocks and learning how to code just by line. Then up here, yep, is the tutorials and a bunch of like activities. So if you want to do stuff on your own, or if you have questions, either while I'm working with someone else or between classes, the tutorials are really great. The activities and stuff. Again, Vex is for over a decade now. They built their whole model around giving people challenges and letting them solve them. So that's what Vex does. And so if you get into it, there's a lot of stuff that you can keep yourself occupied and interested with. And then the file tab, I wanted to briefly mention something because it took me stupidly long to mention. Here we go. So when you eventually, so you're going to want to save your projects at the end of the day. When you save them to your computer, so then you can load them later, next week or whenever you want. You save them locally onto your computer, and whatever the test name that you've given it, up top in the middle of the screen is the file that it saves it as. And you can't change that or you can't change that during the save to your device. Like it's not a save as. You have to give it the name first, and then it'll export the project as whatever you've already called it. So just make a note of that. So go ahead and keep that up to date up top. And then if you make a new project, it'll start out again with whatever the generic name that it starts with. And so you just have to give it a new name. All right, so let's take a look at the different types of functions of different types. You can see colors of blocks that we have available to us. So first things first is the drivetrain blocks. So that's everything to do, as you can imagine, with driving the robot itself. So all the motors connected to the wheels on a Vex robot, behind the scenes, it puts them together in a configuration where it understands what forward, backwards, left, right means. So it does that work for you at this level. So all those motors are already combined together, and so, as well as things that impact how far you're going, like the size of the tires and the gear ratios, and all of that is stuff that when you have an actual robot, you need to play with and figure out for yourself. But for the virtual robot here, it already understands what does drive 100 millimeters forward mean, or whatever you want like that. For this, I believe we're going to try and keep it in millimeters because so it has the option to do inches. Feel free to use those if you want. But all of the challenges and really everything in science is set up to just assume you're working in millimeters or centimeters. This one only does, your options are millimeters. And so Next thing here, we do have one command for the magnet. So the robot has a magnet on the front of it that can either pick up or put down these colored discs that are how you accomplish some of the challenges is by moving around those discs from place to place. And so you've got the magnet there, and again, you can either just turn it on, turn it down. We've got the purple blocks here called looks. So some of those we won't really get into, certainly not yet. So you've got essentially a little printout screen, so you can print things and write words onto your screen if you want. Again, I'm not really going to focus on that, but it is good to know that those things exist. And then the two at the bottom, though, move robot pen down, and then you can actually choose between a couple colors of the robot pen are really neat and useful. And again, we're going to use those as a way of sort of recording where the robot's been sometimes. And so we'll do that. If I might have you draw, essentially solve a map using the robot, right? We're going to do that later today. And so you're going to want to draw a line on the maze where the robot's been. All right, the next guys, all these orange, yellowish orange ones are under control. So we're going to get into that at the end of the day and a little bit next week, where we talk about loops and decision and logic, essentially the brain of the robot that you're programming with the control blocks. Then what does the brain need? The brain needs some sort of sensors telling it what to think. And so you've got this whole category of sensing, which is, again, we'll go through on the next slide all of the different sensors that the robot has available to it and sort of what they can do. You can take a lot of information in, but again, we're going to focus on the logic and sensing parts of things next week, I think. But if we get to it at the end of today, that's a great place to play around with because there's so much you can do. And then in green, we have the operators. The operators, essentially, you understand, it's basic math. They give you a lot of things that you can do to turn the values, the things that you sensed, the results from the sensing, or any numbers that you have, into a different number that's more useful. So again, if you want to turn degrees into radians, you can do that. You just have to multiply it by 2 pi or what have you. So those sorts of operators, again, we won't deal with those much today, but they become very useful when you start talking about control and logic. So we'll talk about that later. And then at the end here, we've got variables and my blocks and comments. Those are really utility. They're never totally necessary, but they make everything a lot easier once you're comfortable using them. I'm going to talk about it a little later today, but everything we're doing for now, you can get by without really focusing on that. But I'll walk you through the My Blocks section because it makes everything a lot easier once you start building a bigger and bigger program. So it's good to play around with that now. So yeah, we've got quite a lot of functions here, and I think that one of the most easy ways to talk about it is to quickly split these into the two biggest categories, which, yep, that's a line right down the middle there, pretty much. And really, you're talking about two separate things. That is the outputs and the inputs. And the outputs are, they're mostly motors in the real world, right? It's a lot of different types of motors that do a lot of different types of things, but most of these are motors, or they're print outputs, or you've got a big magnet. And then you've got inputs and decision-making process. And that, again, that gets much more complicated, and that's where a lot of the fun and creativity of programming is going to come in later on. It'll be good to get to know the virtual robot that we're going to be spending our time with. So I won't go through everything, but I wanted to give you a little introduction to, like I said, so you've got a pen that can draw. Your outputs are, again, specifically, you've got a pen that can draw. You've got an electromagnet that can pick up and put down. And then most of the output that we're going to be concerned with here is the wheels. You're moving around. And obviously the engine, the motor's connected to the wheels. But you've got a variety of eyes that include color and distance sensing abilities. You've got a bumper to see if you're actually hitting something. And then it's the robot's got a sort of gyroscope and location sensor inside of it as well, that you can make decisions based on which direction you're facing and stuff like that. So once we get into the broader Vex systems outside of the virtual robot, they've got a bunch of additional things. Essentially, again, anything you can do with a motor, because you can program motors. That's including making claws, making scoops, making arms that articulate like a big sky crane. And then, yeah, so there's a whole bunch of things that we can do with the robots, and a bunch of other types of inputs that are similar to the ones. Again, you've got a lot of good inputs here on the virtual robot. But once you're playing in the real space, building and designing your own thing, it's really, you've got these tools, and there's tons of ways you can put them together to get what you want done. All right, that's just about enough talking for me for a little while. So this is going to be, again, I want you guys to just start playing around with it. A very simple program, so this is just sort of the 3 steps, 4 steps of making a little program to do a little thing. So again, make a new guy, give it a name. In this case, what I want it to do is start out by just driving forwards a little bit. I want to draw something, and so once I've moved forward into the position where I want to actually start drawing, I'm going to put the pen down, and I choose green because green is my color. I am a big fan of green. And then we're going to draw. And so I just looked up the angles required to make a 3, 4, 5 triangle. So it's a right triangle with those sides as lengths. And so we're just going to tell the robot 1, 2, 3, 4, 5, drive and then turn, and then drive and then turn, and then drive and then turn. And then we're going to pick our pen up, and we're going to back up a little bit to look at what we did. So let's get you guys working. Um, Plan is to separate you guys all out randomly into groups of 3 or 4, depending on the number of people we have at a moment. Start out, everybody break out, introduce yourselves again, get to know each other a little bit. We're going to be here for a while, for a number of weeks. Then go ahead and each of you, but one person should be screen sharing, and you guys can switch back and forth who's screen sharing if you've got questions. But you should each be working on it on your own computer because you want to be doing something different because you're all going to be programming slightly different ways. And that's one of the really useful things is to work with other people and see what do they do that you didn't do and how does it work, which worked better, and learn from that as a group is going to be really useful going forwards. So just start playing around, make a simple program to, like maybe like I did, have the robot draw something on the ground or knock over the castle, or if you're if you're trying to get a little bit of ahead of the class, start playing around in one of the mazes that they give you to use. You can sort of try to solve a maze and then just start giving it commands to do what it's supposed to do. Turn this much and then go forwards, and then turn this much and then go forwards. We're going to get into a little bit of that later today once we talk about functions and some of the ways to make your code not just a big wall of text. But anyway, Drew and I will be hopping around to help. And again, today, I'm sure that I'm going to have a hard time knowing people's names or remembering who's working on what. So feel free to reintroduce yourselves if you see me. But yeah, that sounds good to me. Again, one of the biggest things to think about is that there's a lot of different ways to accomplish the same tasks, and so again, it's good for everybody to be working on their own as well as sharing, because that way you can learn from each other, and also if somebody has a good idea, that good idea should be shared and spread. But that only actually helps if everybody is working on their own ideas, because you'll have some that are good, you'll have some that took 10 lines to do what somebody else did in one line. And so we're all just working together on that. Okay, everybody's back together after the breakout session. First things first, again, a little bit of feedback for my sake. How did that go? Was that too much time, too little time? Did we give you too much or too little guidance? Was that enough of a challenge, or do you wish we had sort of started with the big challenge of the day already and had you start working on that already in just like this sort of baby step sort of way? Let me know. And if you're not in class but listening to this on YouTube, feel free to leave comments about how do you think, is that the right kind of a challenge that I should be giving at this level? I'm happy to know. So we're again, we'll take a little question and answer here, but then we'll get into the second lesson session and then the bigger end of day challenge. So I want to talk a little bit, maybe sort of backing up a bit, but about how to plan a program to accomplish a challenge that you've been given. One of the things there is to write it out either in person or on the computer or whatever, but get it out of just floating around in your brain before you actually start working on any of the code. We're going to talk a little bit about loops, and I've decided to, if we have time, get into functions, which is essentially a special kind of loop so that you can use that loop on your own whenever you want it. And then again, so we're gonna finish the day with the bigger challenge that will get you a pair of coordinates, and we're gonna have you drive to those coordinates in the wall maze. So that's where we're headed. So like I said, if you don't mind, I'd like to, again, sort of start early, drilling in some of the long-term habits that are going to really help with programming once you start getting to big projects that you just can't do all at once. One of the biggest things, the best habit you can get into, is writing good, useful comments on your code. And I use comments also as a form of planning. I don't really like taking notes or writing things beforehand, but writing comments to my future self about, hey, this is what I was trying to do here. If I goofed up, that happens, but this is what I was trying to get done, and this is why. That kind of stuff is really useful to me, and in general, it's useful to anybody you're working with, including future you, because future you is almost always the guy who's going to get stuck with whatever crap you threw together last time when you weren't really thinking straight, and so future you is going to have to fix it. So the other thing there is that, again, planning out the different, breaking down your project, the challenge, into a bunch of smaller challenges, which again, we'll talk about functions and how that's a really great way to do those smaller challenges. But breaking it down makes everything a lot easier to work with. It's a lot easier to not get sort of spaced out by how big the challenge is. And then it's also a lot easier to identify where the problems, where the bugs in your code, if you've broken it down into small enough chunks that you can test, hey, is this chunk doing what it's supposed to? Because if not, that's what's got to be fixed. If you write the whole thing in one giant program it can get really tricky to figure out what's going wrong. Why are we suddenly on the other side of the field from where we thought the robot was going to be based on the plan? Um, so in general, again, comments, you want to be clear, simple. The goal is to convey information, so that's what's most important. In general, I think the most important thing is to just list, hey, this is all of the decisions that are the inputs to this process. This is all the outputs. This is what I hope to accomplish from this little bit of code. And then if there are any key relationships, like, hey, if this input, then that output, just write it there in the beginning comments before you try to actually build a loop to make it do exactly what you want it to do. Put things in words. And again, in block coding, that's not too far different from what we're really doing here. But once you start getting into line coding and designing your own functions, designing your own tools for bigger and bigger projects, it's going to get really complicated if you're not very clear about, hey, these are all the inputs, these are all the outputs, and I know that these inputs are linked to that output. And then the other thing I would say to comment about, and I do this a lot, is if you're doing something, you're not always you don't always want to spend the time up front to get something exactly perfect. Sometimes good enough is good enough. But when you do something that's sort of, hey, this is good enough, but I know that if I spent more time on this, it would be better. I could think of a way to do this better. Go ahead and drop yourself a comment there. Say, hey, this is sort of smashed together because it works for now, but when I've got time, or if something breaks, maybe this is what broke. And so you should go back and fix that later. So the other thing I would say, again, is to have fun with it. Again, so long as you're still being clear, don't call things like alien program number 5. But I have no problem with calling a variable the big turn, or that's a terrible example. Have fun with it. I'm not going to officially endorse cursing in your code, but you know, have fun with it. The other big rule, again, test early and test often. When you've got a virtual playground like this, anytime you do something, go ahead and pop it into the playground, run it, make sure it's doing what you're expecting. Okay, the other bit of sort of fundamentals that we're going to talk about before we get back into the Vex side of things is that loops and specifically functions, building functions, is really the cornerstone of everything else in programming. Is if you dig down one level deeper, you'll see that any function, any tool, any block that you're using is really made up of a bunch of other blocks in either the same language or in a language that's closer to computer language, to machine language, to ones and zeros and ones and zeros. And so everything in coding at the end of the day still has to come down to a bunch of flips and a bunch of flops, making decisions inside of like a tiny little computer. But the reason we can program the way we program is because people have built functions, and then they use those functions to make new functions, and use those functions to make new functions until suddenly we can get a robot to drive all the way around the room with just a couple blocks, and that are totally easy for a human to understand what it's trying to do. And so, of course, why should that ability of turning blocks into functions, turning blocks into other blocks, why should that be just something that the programmers can do? You're a programmer now, you can do it. So we'll talk a little bit about what that means inside Vex, but again, the building new programs and again, what in programming we're going to call functions, is one of the key things that you do to make your code easier to follow, and also, again, like I said, breaking it down into smaller pieces that are easy to test, easy to understand. That's a huge amount of what programming really is at the end of the day. So Vexcode has two types of loops. They've got the basic loops that you have available to you are just wait, which is essentially an empty loop. You're just waiting, and then it has a timer going, and so when some number of seconds have elapsed. So that's really useful if you ever want to slow down the code, but also if you're using some of the more basic functions like turn instead of turn for so many degrees. Well, then you usually would pair that with a wait to say, hey, what is the time that I'm turning for if I'm not giving it a degrees amount. And under the hood, that's really what your robot's doing. Is just we have these more complex functions, again, functions built out of other functions that allow us to do things like just write down the number of degrees, and the robot will know, because we've set it up the right way, how to interpret that. So then the other sorts of loops we have that are very basic and we can use today without any other sort of discussions are repeat and forever. So forever is really nice if you're trying to make the robot be autonomous or just, go on forever. It'll just keep looping in that loop, and it'll get stuck in that loop for the end till the end of time. So don't ever put something after a forever loop. Unless you've got some clever way of getting out of it. But the repeat, it does exactly what it says on the box, right? It repeats that many times, and then it keeps going. So the example I have here, that just drive forwards and turn right for 30 degrees, repeat that 6 times, you're going to get a hexagon. Or maybe half a hexagon? 30 times? Half a hexagon, whatever. So, so that's loops are really easy to use. That again, if you're trying to do something that looks like it's a repeated task, don't write it out that many times. Just repeat that task however many times you need to repeat that task. And so, learning how to spot those things that you could just repeat this makes your code a lot quicker, just a lot easier to write and easier to read. Again, we'll talk a little bit more later about more complex loops, but the complex loops you have available to are essentially repeat until and while, which again, they're just the opposite of each other. So while keeps repeating itself so long as this thing is true, and then repeat until keeps repeating itself until this thing is not true, or keeps repeating itself until this thing happens. Yeah, It says, yeah. So the example here being one of the eyes detects red, like for instance, if you're about to fall off the map, maybe you want to do something about it. Or, I guess in this code, maybe you want to drive off the cliff. So, all right. So again, this is getting a little bit ahead of ourselves for today, but I do think it's worth, again, because it's so important to the rest of programming, to talk about building functions in Vex code. For now, let's keep it a little bit simple. So don't worry about, again, you can add inputs to your Vex code. You can either have them have an input a number or input a Boolean, which is a true or false, or you can just add additional text to keep explaining things. And you can create those numbers as variables that you can use inside of your function. So again, that's obviously really useful, but we'll get into that with logic and decision making later. Feel free to play with it if you want, but that's not going to be the focus today. But when you create a function, you get a define block, which is that pink one with the curved top, so it doesn't look like it's a puzzle piece on top. It's just a puzzle piece on the bottom. And so everything you connect to that on the bottom, the top, it floats on its own anywhere you want on your notebook. But anything you connect to the bottom of it is going to be the code that gets run anytime you have the little pink one, the call function, calling that function in your normal code. And so you can collapse all of these commands into just anytime I say, hey, wide left turn, what it's going to do is say, okay, we're going to execute wide left turn. And what that means here is we're going to drive forward for a certain amount, and then we're going to turn, and then we're going to drive forward a certain amount. So again, you can see how this makes it really easy to make the biggest part of your program just a very simple list of if this, then this, and then the if this, then this can just be one line, and then you can explain what that means somewhere else. Okay, let's get you guys back to work. So let's choose a letter or number, or letter, one number from A, B, C, D, and 1, 2, 3, 4. No looking at the map. Come on, come on. Maybe we'll randomly assign the numbers. I don't know. We'll see what's the right way to do it. But go ahead and open up Wall Maze and make a plan for how to get to that letter and then to get to the number. Again, things to be thinking about if we want to get a little more advanced and make your code a little bit better. Do any of those sort of moves that you need to do they repeat? If they repeat right one after another, stick it in the loop. But if you have a move, for instance, again, move forward, turn, then move forward again. If you have something like that that repeats a couple different times in different places, wouldn't it be really nice to just make a function that says, hey, do this type of a move, move like a chess knight or something, and then give it that instruction, and then you can just use that instead of having to copy and paste the big list of tasks every time. So anyway, the challenge is, to drive yourself to whatever the letter you chose is, and then draw a line to connect that letter with the number that you chose. Of course, again, yeah, if what you want to do is to hard code it, by all means, that's fine. But again, for this, it's just going to be a big, long wall of code, but it's perfect. It's going to work if you want it to work that way. But the challenge is to try and make your code as efficient as possible by maybe you do write the whole thing out first and then look at your code and say, hey, I noticed that this repeats a bunch, so maybe I'll stick that as a function. So again, there's a lot of good ways to do it that are all correct answers. But I guess I should ask you guys: do you feel like working in small groups again to do what you're to do this tasks, or do you just all want to stay and you can ask me questions in the chat here as a group? Just let me know. Again, we'll work on that for next week. Figure out what do you guys like the most.